Hi everyone, it's time for a tech talk with Kitronik again. I'm Emma, graphic designer.
And I'm Alasdair. I'm one of the electronic design engineers here. Yeah, it's nice to be back.
Yeah, it's been a while since the last one, and today we're doing the
Yes, today we are looking at the Pico Smart Air Quality Board. This is one of our new products. It's kind of a bit of an overview. It's an environmental monitoring, data logging, and sort of output control board designed specifically for the Raspberry Pi Pico. And yeah, that's a really brief overview, but we're going to be delving into more detail as we go through this tech talk today.
Mm-hmm. So, can you tell me a bit about what's on the board?
Yeah, I can tell you a bit what's going on. Just always, as always, a reminder, if you've got any questions, it'd be great for you to put those in the chat. Mark's going to be monitoring that for us, and he'll let us know what you've got. We'll do our best to answer them for you now. If you're watching this sort of on catch-up later on, do feel free to put comments, and again, we'll try and answer those as best we can as we go on. So, what was it? We wanted to look a bit at what's on the board.
Yeah. So, sort of what's going on and where it is on the board.
Great. Let's switch to the demo cam so we can see, give you guys a bit more of an idea what we can see. So here's your first look. This is the board itself. As you can see, there's quite a lot going on. This is quite a jam-packed with features board that we've done here. So let's go around them sort of one by one, and then we can sort of show you how to use them. That's a bit later on with another demonstration. So kind of the main one we've got here, the big feature, although it's very small physically, is the BME 688 sensor. Now that does air quality, estimated carbon dioxide, temperature, pressure, and humidity. So all in one, you've got this package here that does all that sensing for you, and then we can go and use all that data to drive various other things. If you wanted to view what's going on, we've got a little OLED display screen here. You can put a nice little black and white, put text or graphics. We could even do a bit of graph plotting with that as well. We've got some control buttons so that you've got some interaction as a user. Later on, we're going to show how you could perhaps have a menu set up to do various things on your board, or you might just want to control specific actions with that. The Pico slots in here. That's what these double rows of headers are for, so you can attach the processor, but still have easy access for where the USB cable comes in. Then we've got a whole bunch of outputs. So we've got a buzzer for some audio. Along the front here you can see some little zip LEDs. Those are fully controllable RGB LEDs, which are great for perhaps providing some status of perhaps if your air quality is really bad, you want to show red so you can sort of get out of the room as quickly as you can. We've got a servo output here, and then next to it we've got an output for more zip LEDs that you might be doing some sort of lighting. And then either side on these big terminal blocks, these are high power 1 amp outputs for controlling devices, perhaps like a motor or a fan. On one of our other boards we do things like a water pump for a smart greenhouse setup, or something like a heater. Any of those things, it's great for controlling those higher current outputs. Up here you can connect some extra sensors. So this is an analog input area. Some of them are solder pads, but one of them we've got a nice little 3-pin header socket just for ease of using. Those are kind of the onboard features. I guess we usually look at powering options. So you can either provide power in through this terminal block, so that could be a wall power supply that you've got broken out to wires, or you could put a solar panel in. And a solar panel is great because if we flip to the back, we've got a built-in battery cage, which means this is very portable on the go, and that could either use rechargeable batteries, so you tie in nicely and charge them with your solar cell, or you could put in normal AA batteries that keep this powered for a good long time. And if you're not using lots of the outputs, this will last a long time on doing perhaps some minimal data logging program that you've got running for a good long time. So there you go, that's all the features on the board. When you combine that with the Pico itself, that's actually got an onboard real-time clock, so you can get really accurate time and date stamping. And it's also got a big load of memory, so you can write your own data log files full of all sorts of information. Yeah, that's quite a lot of information. I appreciate.
So yeah, it seems pretty involved. So it sort of is that it's aimed at maybe older learners, or?
Yeah, I think this is definitely the target audience for this board is secondary school pupils. This is probably a bit too advanced for primary school, particularly as we'll go later on. It's programmed not in a visual language, it's programmed in text-based. But this is ideal for secondary school or home users. I can see this fitting into ICT lessons, computer science, DT, science, or even geography, where you've got this nice combination of the environmental factors you can look at, data logging, and then data manipulation and analysis with the files you get. Or in DT, you could build some sort of enclosure for perhaps a weather station or monitoring station, or building in a sort of like a demo setup of something, like you might see later on. Or home users as well, I guess. Air quality is pretty, perhaps in the off the back of the pandemic, we've been thinking about air quality a lot for various different reasons, and actually being able to monitor your air quality at home could be a really good thing that you want to do, and as such, this board's ideal.
That's a nice idea, yeah. So how can people get hold of it? How much is it?
I think the website's probably a great place to go for seeing that information. So Kitronik's website, we've got all sorts of information. You want to drive down and we can kind of see bits on the page if you want. Yeah, so at the top we've got some nice pictures, courtesy of yours truly there. Not yours truly, that's myself, isn't it? Then we've got various bits there, and then as you scroll down the page, we've got some of the key features unpacked, and then a bit more information below that, detailing kind of perhaps most of the things I've said, but fleshed out a bit more, and again pointing out some of those features with a nice breakout diagram. And if you keep scrolling down, we've got again those features, and a bit of a product video if you wanted to catch up later to just have a reminder of what's on there. And then there's some extra resources as well, which we'll look at in a minute. But on the right hand side, we've got the pricing. This is a bit more of an expensive board. It comes in at $32.50 ex-VAT. But as we've seen, there's just so much going on here. There's a lot of really good features, and there's a lot all in one place rather than having to combine perhaps some different boards together. Instead, it's all here. It's got the power, it's got the outputs, the inputs. Everything's all there. You just got to go with it. And adding the Pico itself, which is really quite cheap, means this is a really good, actually really cost-effective monitoring and logging and control station all in one. And there's also price breakdowns for if you're buying this in bulk, perhaps particularly if this is for schools. You've got some of those cost savings brought in there.
That's always nice. So obviously, I touched on earlier, it might be a bit complex for younger learners. What languages does it use?
So this board, as it's using the Pico, the Raspberry Pi Pico, it uses Python, or really a breakdown of Python, a MicroPython setup. And actually, we've got, if we hit the first link just there, so we've got the data, or second link, sorry. Just click on that one.
Okay.
What we've got here is actually Kitronik's written a nice library in MicroPython, just make it really easy to get hold of that base code and start writing your own programs. So on our GitHub page, you can just go and if you went to this page here, you can go in and view the files. So this is the library itself. You've got all that code, and then back on the main page, there's a sort of a breakdown of how to use each different section of the board, which is great. If you want to kind of have a reference to go and look at, we've got some example projects, and we've got some tutorial code. So that's all there and available for you to download to get started straight away. And if you're perhaps new to Python itself, we've got some tutorials on the website, and we've actually got individual tutorials for all the different sections of this board. So this one is starting out how to use that really good sensor to start with. And it's a really nice, easy to follow blog-based tutorial. It takes you through how you set it up, how you turn it on. If you needed to go off and find how to use the Pico, there's a helpful guide to get started. If you've never used Python, how to get started. So it's all nicely laid out, ready for you to go through, and it takes you through step by step. Really simple program, just to get some values out to start with before you can go and do some more interesting things with this product.
Speaking of interesting,
we've what is interesting?
Oh, we've put something together between the two of us to demonstrate. So
Yeah,
Alice
so
is going to move the cameras.
Move the cameras around, do a bit of witchcraft in the background. Yeah, so this is a program that, Blue Peter moment that I prepared earlier. So this has been written, and if you do the tutorials online, it'll talk a lot about Thony, which is a really nice development environment that's really great for beginners in Python, because it's got it's laid out really nicely and it's really intuitive to use. And we've got some other blogs that tell you about using that. So we've written a program in Python, and this is sort of almost like a smart house, smart building setup. I think that was kind of the inspiration for this. Probably lots of you have got some sort of smart feature at home. I know that we've got, I like those light bulbs that you can turn on and off with your phone, and I did have a smart heating system, but I've moved house and failed to install it again. But there's a lot more of these features coming in either where we're living or the places we're working. I had an opportunity a few years ago to go to quite an incredible building in Amsterdam called The Edge, which is this incredibly futuristic building that's just jam-packed with sensors, and everything is controlled to the nth degree of, you can control your lighting and your air conditioning as an employee to within a 2-meter radius of yourself. It monitors the energy consumption. I know, it's great. And it knows where people are in the building, so it can turn off the power and really save energy. So I think smart homes and smart buildings are really coming. And this kind of board, although it can't control an office block, probably this is like one of those sensors that's got everything all in one, that you can begin to understand perhaps how you might control and what might be going on in the real world in some of these places. So I've written this program. I think we're going to make this available afterwards. Is that the case? This whole setup?
We'll have a blog up. Watch this space. It'll be available on the website.
Great. So we look forward to seeing that go live with some of Emma's build as well on this. So this is a program that's, it's essentially, if I switch to the demo cam, it'll probably be easier to see. Let's just zoom out a little bit more, shall we? Excuse my lifting up. This is quite a large model, so you may just have to bear with. So basically we've made a little smart house. We've got a window, always ideal, a skylight, which is going to be servo controlled to open or close. We've got the big yellow pad in the bottom with some underfloor heating, very swish. We've got a solar panel on the roof for some nice renewable energy. And then inside, which you can't see but you'll see when we switch them on, we've got some lighting using one of those external zip sticks. And down here in the bottom we've got the board with the Pico plugged in this time, controlling all these features. So if we switch it on, it'll run through its initial startup phase. There we go. We've shut the window, and we're going to start out with things, very standard. But what this is doing, whilst it's just sitting here, look like it's not doing anything, it's carefully monitoring the temperature and the humidity. And if things got much hotter, then we would open up the window. So I might move around and just try and warm this up a bit. It might take a while to get hot. I'm going to breathe on it. I'm very sorry if you can see my face on the camera. Am I in?
No, you're fine. You're fine.
There you go.
High-tech solutions here, folks.
It got too humid inside the house, and so to sort of release some of that air, we've opened the window. If it got really cold, I don't know if it's snowing where any of you were. It was snowing here a little while ago, and things were very chilly this morning. You'll be able to see that the window will shut, and hopefully on the board, you'll be able to see on this side, a red LED will come on to indicate that. We need to turn the heating on. We've got some freezer spray, which is used for testing here. While that's going, it's probably quite hard to see the screen. You see the window shut, and the little red LEDs come on. It got really cold. It got down to 5 degrees with that freezer spray. We're doing some of that simple control like that. It's looking to see what the conditions are inside the house, and how we might then adapt the environment using a control system that's constantly feeding back that data to see what's going on. We've also got some lighting in here. Now that will turn on when it gets to later in the evening, but we've probably not got time to wait that long for the evening. So we've also got a little system in here on the menu system we've got, which we can zoom in and have a look at in a minute. But there is a lighting control board. So if you wanted to turn on some blue lights, you can see a sort of blue haze has come in to the screen. It's always nice having those. What else do you want? Maybe some red. Oh, there you go. A nice red light. That's some evening relaxing time. I don't know. Do you ever use? I don't know. I don't use coloured lighting in the house, but maybe I'll have to get a smart bulb that does that.
Yeah. No, it's definitely a popular thing now.
It is. RGB lighting is all the rage. And I'm going to kind of try and move in again to show you what's going on in the control system of this board. Please excuse just the slight movement that we've got to do. There we go. Hopefully you can see the camera is struggling to kind of fix on the screen just because it's the refresh rate of the screen is quite low compared with the how much the camera is doing. But you can see there are menu options. We're scrolling through. We've got this light control menu. Yeah. Or we've got a device status. So it's very hard to read. I do apologise, but it does tell us that the window is open, the heater is off, and the lights are on. And we've also got a data readout. So this is telling us the current temperature, pressure, humidity, the air quality index, and also the CO2 levels. And that's what these LEDs at the bottom are showing as well. I do apologise for the focusing.
If you move that light down, you'll probably get some focus on it.
There we go. It was so close.
Try a bit closer. Try a bit closer.
You can see the LEDs at the bottom. There we go.
That's nice.
There we go. And that's showing us that the air quality and the CO2 levels are good. If I kind of spray a bit of this stuff in again, you can see that the air quality and the CO2 is really bad because of the chemicals that are in the freezer spray. So they've gone red. So you've got a nice little indication with those zip LEDs on the board of the immediate situation of your air quality and your CO2 levels, which is really helpful to see. And those numbers are updating on the screen for you. Because the temperature went down, was it now 5 degrees maybe? Mm-hmm. The window has shut and the heating has also come on again. So that's really helpful. I think that's probably the full hardware demo, but I think that one of the other really important features of this board is the data logging, because it's all very well having all this stuff updating live, but if you really wanted to go into like really seeing what's happening over time, and I guess this is how big smart homes and smart buildings, they've got all that data log that they can go back and look at trends of what's happening over time, and perhaps those like thermostats, they start learning about your daily usage patterns or what the daily temperature is at different times of year, so it can begin to adapt its cycle. So I've not written that bit in the program yet. What we do have is the data log file itself. Thonny's great for this. It's got a nice file view, and if I just make sure we can link up, I've just plugged in it's just simply, if I just show on the demo account, a micro USB lead plugged straight in there. It's really handy for being able to communicate with your PC. You'll see that we've got this. These are all the files that are on the Pico. So there's one called house data, which is, that's what we've got. And I've run it a few times, but you can see this is the latest one we were just running just now. So I've got a little heading, just tells us the climate sensor readings for our smart house. It looks a bit hard to read at the moment, but what this is a text file that you could import into Excel or another spreadsheet program. And we've logged the date, the time, what the temperature was, the pressure, the humidity, air quality, the CO2, and also whether the window was open or closed, the heater was on or off, or whether the lights were on or off. And you've got all this data. This was logging every 30 seconds, so we've got a good amount of data, in there. and if you wanted to go and analyse and see what's happening over time, maybe you're doing this over several weeks. Maybe this is a school project where you want to see how things change in some of your different classrooms, and you can compare the data readings you've got in different areas of the school, or at different times of year if you wanted to extend that project longer. This is just great because you've got so much data. You can store thousands of entries on the Pico, and those files are really easy to access and then go and import to a spreadsheet program to manipulate. So I think it's great. I think we've touched on perhaps a small set of what you could do with this board. I think the potential and possibilities are really quite big, just because there's so much there. And the Pico is great for being able to program. Like the MicroPython build for Pico is really, really helpful. There's a lot of useful other material out there for getting started with Python itself, and because we're always writing modules that go along with our boards and example programs to get you started. I think it's really great.
Yeah.
Hopefully
that's amazing. Yeah, I definitely know more now.
That's good.
Yeah, but no, that's really cool. I can see a lot of very nice modules that could be cross-curricular in schools potentially, and definitely learning about smart homes. Yeah, that sounds awesome.
Yeah, I think what you've just said there about cross-curricular, I think this is probably something that's coming more. We don't want to be just fixed on doing one stream at a time of different lessons, and actually if we can combine across subjects, I think that's a really good thing for people to learn, because when you get into the real world, we're not all just doing one thing. Yes. I mean, you're a graphic designer, but you end up writing bits of software sometimes, don't you? Learning about electronics, I think, in ways that you didn't really think you would before. I end up doing graphics sometimes, which just doesn't go as well. So we're not fixed in one particular stream of things. So actually being able to do stuff across the curriculum and work together is really really good.
Exactly. So it was really nice to chat about this today. If anyone, again, if you've got any questions, Mark's in the comments right now. You can always message us afterwards as well. Drop us an email, write in the comments of this video. All of that, we will do our best to get back to you. And is there anything else to say about the product itself that you'd like to go over before we finish?
I think just summarising that it's not just a data logging board. It's not just a monitoring board that gives you live updates on the screen, and it's not just ability to control outputs. It has got it all together, and I think that's what's really nice about this system. Is it's all together. That's what we've called it. We've called it the Pico Smart Air Quality Board, because it's smart things take in information and actually make use of it rather than just storing it for use later. It can do things on the board itself, which I just think is really good. That's probably it. I think that's a good. I think that's a nice overview statement. If there's any questions, probably got probably about a minute or so for you to get those in. But as I say, if you're watching later, do put those comments down, and Mark or one of us can get around to answering those.
Yes.
It was nice to be chatting to you with this today. Kind of
nice to
you've come into this properly as a beginner on this, haven't you? Which has been nice to have a learning experience.
Definitely. I've not done much with Python or MicroPython, so I'm very excited about doing some. This make as well will be on a blog. I'm excited to do some more makes with potentially this board. Or other boards that are air quality monitoring. So watch this space for some of that in the future. I'm sure myself and Alasdair will do a few collaborations. Mostly because I don't know how to use Python properly. So
but that's why we work together, isn't it?
Yes, exactly. That's the good thing about collaboration. So thank you everyone for watching. I think we're about to end, so maybe like 15 seconds if anyone's got any quick questions, but like we said, message us, and thank you all for coming.
Thank you. It's been really good, so hope you enjoyed this.
Thank you.